Hello Miller's Planet citizens. If you're new to the channel, welcome, and if you're not, welcome back. I've got a very special video for you today. But before we get started, this video has been sponsored by Cody, who is a sheriff. Hey, just stopping by real quick. I know you're really busy, so I won't take that long. I'm just stopping by to say thank you again so much for sponsoring my video. That was really cool of you. Now, sadly, Cody does not have any opposable thumbs, but do you know who does? I do, and me and my opposable thumbs have been building this for the past month. This is a remotely controlled robotic hand. Now, I wanted to take on this project not only because it looked really fun and interesting, I wanted to get more hands-on experience with remote control modules like this one. So before I got to building this thing, the first of many steps was figuring out what I wanted this thing to be able to do. Like as a robotic arm, in terms of hand gestures, what was it going to be able to replicate? How much freedom was I going to be able to give this thing? Was it going to be just my fingers? Was it going to be my wrists? And what would be the limiting factor? The rest of the project really relied on those questions being answered, so I went ahead and answered them first. So step one was going to be figuring out the robotic arm's freedom of movement. Well, first off, I knew regardless of where the robotic hand was going to be able to move, the movement information was going to be coming from my glove. And to translate my hand movements into transmittable data, I would need to use tactile or flex sensors. It's kind of weird how they work. While they're flat and unbent, the resistance is lower, but when they bend, the resistance goes way up. While flat and unbent, my Arduino's analog read function picks up a 1023 or high voltage. For those of you that know how the digital mapping of analog read works, good for you! But if you don't, I'll get into it later. When they bend, the resistance goes way up, and my Arduino's analog read picks up a 0. So I was doing some research on flex sensors, and it turns out they're kind of expensive. And what if I broke one?
I don't even want to think about that.
But it turns out I could make my own at home. I gave it a Google, and it turns out there's like a 50-50 split between two different methods. One was just using graphite and aluminum foil, and just a piece of paper with graphite on it, like pencil graphite, and that did not work at all. I tried a bunch of different iterations of that. It sucked all the time. That doesn't really make sense. Every time it sucked. The other method was just using aluminum can cutouts. It was just two pieces of soda can cut out, placed back to back with output wires. Very simple. And it worked very well every time. There was a drawback though. It was either 1023 or 0. There wasn't any kind of in-between value. It was just high or low. Let me try to explain that better. There was a threshold bend angle which had to be reached in order for it to get to 0. It went 1023, 1023, 1023, 0. And I tried adding a couple different things, like I tried increasing and decreasing the capacitance depending on how far they were apart, putting different conductive materials between the two plates. I tried out a lot of different resistors. Nothing really seemed to get rid of this problem. It just kind of increased or decreased sensitivity. Wasn't that big of a problem, more just like a minor inconvenience. This turned out to be my limiting factor because my wrist does not do that angle in this way, kinda. But the results were too unreliable, so I decided to scrap the idea altogether. So I knew that I was going to be using 5 fingers on this robotic hand, which was going to require 5 servo motors, but that was pretty much it for required parts. The rest of the design was up to me. That's complete freedom right there. Step 2 was wiring up the glove, but first I had to figure out just what the hell I was doing with those remote control modules. So after doing a ton of research on how they work, what pins go where, and what the code should look like, I started off really small. I got the receiver and the transmitter to send simple messages back and forth to each other. After I got that working, I tried transmitting analog data from my flex sensor to the receiver module and setting up a couple of if statements to control a servo motor with that input. Then it was time to bust out the sewing needles. If we have any sewers watching this video, please don't roast me for my sewing skills. Okay, thanks, bye. I knew what parts were going on the glove, the Arduino Nano, all 5 flex sensors, and then all the wiring. I would just need to plan out how the parts were all going to fit onto the glove before I sewed them down, which was pretty easy. The part that was not easy was the sewing. I was brand spanking new to sewing. I had never done it before, and it took me like 2-3 days to get like mediocre at it. So step 3 was building the hand. The first thing I started thinking about in terms of design was how the fingers were going to bend. So I went on Amazon and I just started looking up like hinges, something that you could screw into a solid piece of something. I didn't know what yet, but also could be flexible. I found these bad boys, and the rest of the design kind of fell into place after that. I knew I was going to need some kind of lightweight material, but I couldn't use like cardboard or styrofoam because you can't really screw anything into either one of those materials. So I started thinking like wood. I went to Walmart, picked up some balsa wood. That stuff is not only lightweight, it's strong and sturdy. It's pretty easy to like cut through and shape, so it turned out to be kind of perfect. To get each finger to bend and then recoil, I needed some kind of string that was really flexible but also strong enough to withstand all the bending. I bought this stuff on Amazon, not really knowing how well it was going to perform, but it turned out to be
pretty rad.
And cue the build montage. And step 4 was the coding. I'm gonna go ahead and leave all of the codes in the description along with like circuit schematics and all the parts. But it's actually pretty simple when you get comfortable with the code for the transceivers. You're gonna have 2 pages, the receiver and the transmitter page, and you're gonna wanna make sure that the library for the transceiver is on both of them. Then you're gonna wanna make sure that both of the pages are using the same sending and receiving addresses. Then there's the code that tells the transmitter to give the receiver all of the analog values from the glove in a message string. In the receiver code, you gotta have an if available statement saying, if a message comes in at that address we agreed upon, I'll go ahead and open it for you. That would actually be really nice. Thank you. Thank you so much. Then you gotta have a radio read function that takes in the actual analog values from the glove. That's pretty super duper. That's so cool. Now I can turn on those servo motors
because I have all the analog values.
Step 5 was something that I was really nervous for. Step 5 was testing. Of course, step 4 and step 5 kind of happened at the same time. I spent a lot of time twerking tweaking the code, figuring out what worked and throwing away what didn't work. I started out by controlling just one finger. That worked, and then I moved on to all 5 fingers. But unfortunately, my flex sensor started crapping out. I think like 2 of them started like physically cracking after all the rigorous testing. The rest of them either had flimsy wire connections or just weren't sensitive enough after I sewed them all down. So my thinking was just like, I know what to expect from these flex sensors now. I'll just go ahead and redesign them and create a new glove. Part 5.5, building a glove that actually works. First, I added thicker wire connections to make the glove more reliable. Then I tried putting the connection wire through a sheet of aluminum to make sure that the entire piece would conduct, and also through a piece of paper to make sure that it would stay in place. It seemed like a good idea, but for some reason it just did not work. While I was using the glove, some of the connection wires would just slip right out. And I know what you're thinking, why didn't you just solder them down? It would not solder together together, it just wouldn't work, it would just fall off. Eventually I just poked a little hole through each piece, sent the wire through, and then taped both pieces down. In terms of stability, that worked like a charm. After sewing each of these sensors down, I tested it out before moving on to the next one. This worked out really well. After a few days of sewing things down, it was ready to go. Also,
I'm such a good sewer now.
and I had all the code already written, so I just went ahead and tested it, and it worked pretty well right off the bat. So here's the footage from that. I think I finally have a name for this thing. I am thinking Archard, a rotationally challenged, hand-assembled robotic device. It is a real name, by the way, if you were wondering. So why give this one such a weird and crappy name? Well, foreshadowing alert, this is probably going to be like a Mark 1 in my robotic arm series, unless I die or join the circus. Maybe even an entire robotic arm. If I deem it to be worthy and cool enough, it'll get a cooler sounding name. Not that this wasn't cool enough, it turned out marvelously, but still a Mark 1.
An intermediary version.
Thank you guys so much for watching. Press the like button to lock in your like. Anyone remember that Facebook scam artist?
Push the like button.
No? Okay, bye bye. See you next time. Really
Do
do
it.
it.